Dear experts and colleagues, hello. It is a great honor to have the opportunity to exchange and share sports research issues with you in this international arena. The next paper I'm going to report to you is called The Effect of Velocity-Based and Percentage-Based Strength Training on Lower Body Physical Performance of College Recreational Badminton Players about Olympic sport. I will briefly elaborate this paper from four aspects: introduction, material and methods, results and conclusion. First of all, I will make a brief summary of the full text. Badminton players require sufficient lower limb strength to respond promptly and effectively to various changes in shuttlecock trajectories during matches. Velocity-based resistance training has emerged as a novel resistance training method in recent years to enhance strength and power. However, no study have yet applied individual low velocity profile to badminton players to investigate the effects of VBRT on lower limb strength. This study aimed to explore the effects of VBRT and PBRT on lower limb strength in amateur badminton players through an 8-week experimental intervention. The experiment shows the VBRT and PBRT training have different effects on different strength index. Next, each part will be elaborated in detail. The first part is introduction. Firstly, the characteristics of badminton and the demand for lower limb strength are explained. A badminton match typically lasts for 40 and 60 minutes, with a work-to-rest ratio of approximately 1 to 2. Real life within 10 seconds account for over 18% of the game. Athletes must possess sufficient maximal lower limb strength and various jumping abilities to swiftly move into position and maintain stable lower limb posture, thereby enabling timely and rational response to various structural trajectories during match. Then it points out the function and effect of traditional resistance training. Percentage resistance training. Resistance training offers numerous benefits, including muscle hypertrophy, increased muscle strength, and endurance. This not only enhances athlete performance, such as jumping, short sprint, and changes in direction, but also plays a significant role in injury prevention and rehabilitation. Designing an effective RT plan requires careful consideration of various training variables, such as exercise selection, order, load intensity, volume, and rest intervals. Traditional percentage-based resistance training typically sets loads based on at least one repetition maximum. However, athletes' training status and performance are influenced by various factors, such as daily psychological and psychological state, sleep, and nutrition. Daily 1 RM may fluctuate by up to 80%. Coaches can only adjust based on personal experiment and athletes' subjective feelings, which may not accurately reflect athletes' actual conditions, thereby affecting training effectiveness and even leading to sports injuries. Recent studies suggest that inaccurate training not only failed to improve athletes' strength levels but may also lead to a decline in competitive performance. Therefore, coaches and researchers believe that establishing reasonable training loads requires considering a series of influencing factors, such as load intensity, volume, set and repetitions, inter-set rest, exercises sequence, and training type to ensure appropriate loads, prevent overtraining, and improve training effect. The principle and advantage of resistance training based on speed and point out again. And then the role in badminton field is introduced. The increasing popularity of strength training monitoring device has attracted the attention of coaches and researchers. Linear sensors have become an effective tool for monitoring velocity in strength training. The accuracy and reliability of this device have been confirmed, with measurement errors within acceptable range. Velocity-based resistance training has emerged as a method of automatically adjusting loads in recent years. Coaches utilize equipment such as streamwear and teeth-force linear sensors to adjust training loads according to training goals. Breaking away from the rigid approach of fixed load arrangements based on 1 RM percentage for strength training. However, no study have yet applied individual load velocity profile to badminton players to investigate the effects of VBRT on lower limb strength. Recruitment involves 33 amateur badminton players from universities. Participants were randomly assigned into 3 groups using SPARS, VBRT, PBRT, and control. The whole experimental procedure is divided into 5 steps. The first step is to familiarize the subject with the intervention and test action. The second step is to develop the strength speed curve of each person in the VBRT group and design the training load. The third step is the test before the experiment, including the test of 1RM, CNJ, SJ, DJ, RSI, and SLJ. The fourth step is the intervention of the 8-week experiment. The fifth step is the test after experiment. After 8 weeks of experiment, this section includes comparison of results within and between groups. Intra-group results show that there were significant differences between the VBRT and PBRT groups in all 5 indicators before and after trial, while the control group did not. The intergroup results show that the VBRT group's improvement effect on CNJ, SJ, SLJ, and DJRSY were all due to PBRT group, but worse than PBRT group in squared 1 RM. Therefore, the following conclusions can be drawn through this experiment. 1. For amateur badminton players, the VBRT group showed significant improvement in vertical jump performance compared to the PBRT group, indicating the effectiveness of this training method enhancing vertical explosive. The PPRT group exhibit better gain in maximum stretch and lateral jump performance than the VBRT group, suggesting that PBRT may have an advantage in improving maximum strength and horizontal explosiveness. Regarding perceived fatigue, there was no significant difference between the two groups. This indicated that the subjects had similar presentation of overall effort and difficulty. However, it is worth noting that the VBRT group had a higher absolute load during training compared to the PBRT group. Thanks for listening.